Hi everyone. In this video, we'll discuss a few problems on regular channel section. Okay. The first problem is find the width and depth of the rectangular channel to convey a discharge of 1.45 meter cube per second at a velocity of zero point 0.5 meter per second. The bed slope of the channel is 0.0001. Take Manning's n equals 0.014. See, whenever the problem on the channel section, first you have to decide what is the channel section he has given. Either it is rectangle, trapezium, triangle, or circular. Okay. So in this problem, it is very clear that he has given a rectangle channel. Next, you have to check whether the given channel section is a regular channel section or the most economical channel section. Here, nowhere he has told anything about the most economical one, or nor he has given any sentence regarding that. So we'll take this channel as a regular rectangular channel section. First, you write down the given data first. Okay, width and depth you have to find. So here the width I'll take it as B, then the depth of the flow I'll take it or depth as D. These are the width and depth you have to find. He has given discharge capital Q equals 1.45 meter cube per second. Next, he has given velocity V as 0.5 meter per second. Then bed slope I have taken as I, that is 0.0001, and he has given Manning's n equals what? 0.014. Okay. Since it is a rectangle channel section, so first let me write from the continuity equation. We can write Q is equal to area into what? Velocity. Here Q is given as 1.45, area is unknown, into velocity is 0.5, and if you find out the area, it works out to be 2.9 meter square. Okay, but we know that for a rectangle, area is equal to what? Width into depth. Therefore width B is equal to area is 2.9 divided by D. You keep it one side because both D and B are unknown. Next I'll write what is wetted perimeter, which is equal to B plus 2 times D. Therefore wetted perimeter is equal to B is 2.9 divided by D plus 2 times the depth is your wetted perimeter. Okay. uh, Now what I'll do is, you keeping this wetted perimeter and the area on one side, let me write the velocity formula. Velocity V is equal to C into root of m into what? I. Okay, then the velocity V is given, okay, so as 0.5, but C value is not given. Instead of C, he has given what? Manning's n. So for that, the relationship between C and n are 1 divided by n, m to the power of 1 by 6, square root of m into I is what? 0.001. Okay, now you further simplify. 0.5 is equal to, you substitute the value of n, and let me take this m as 1 power 6, then root m I take it as m power half, then square root of 0.0001. Okay, so you solve for m here. Okay, then your m value works out to be 0.585 meter. Once you know the value of m, we know that hydraulic mean depth m is equal to area divided by wetted perimeter, which is equal to area as 2.9 divided wetted perimeter equal to 0.585. You get the wetted perimeter value. P works out to be 4.95 meters. Okay, so P is equal to what? 4.95 meter. Now you substitute this P in this equation. You substitute the value of P in this equation and you solve for what? D. Okay, you get, so I'll write it here only, that is 4.95 equals 2.9 divided by D plus 2d. You simplify, you will get the value of d as 1.52 meters. Further, you substitute this d here, that is 2.9 divided by 1.52. You get the value of b as 1.91 meter. So these are the width and depth of an rectangular channel. So we have just, I went from the basics only. Okay. Now the second problem, a rectangular channel conveys a discharge of 9.6 meter cube per second. If the width of the channel is 6 meter, find the depth of flow. Also find the average shear stress at the contact surface. Bed slope equals 1 by 5000. Take C equals 54.62. So in this problem, if you observe carefully, you have to find the two quantities. That is, one is depth of flow, another one is average shear stress. Let me find the depth of flow first. You just write down what are the given data in your problem. That is, discharge value A is given, that is Q is equal to 9.6 meter cube per second. If the width of the channel B is what, 6 meter, then depth you have to find D equals question mark. Also find the average shear stress. Shear stress I'll take it as tau. Then bed slope is given, I is equal to 1 by 5000. Then C value is given directly, that is 54 point what, 62. Okay, so here what I'll do is I'll write the discharge value here, that is Q is equal to what, 9.6 meter cube per second. Now just you write area. Area is equal to B into D, that is 6 into D, 6D. Then wetted perimeter is equal to B plus 2 times the D. Then M is equal to hydraulic mean depth is equal to area by wetted perimeter, which is equal to 6D divided by 6 plus 2 times D. Now we can write velocity V is equal to C root of M into I. Okay. Now uh, here the velocity value is not known. So, and also the area is not known. What I'll do is I'll write discharge is equal to area into the velocity. Okay, then discharge Q is equal to area into C into root of Mi. Discharge value is given as 9.6, area is 6 into D, C value is 54.62, then root of what is M here, that is 6D divided by 6 plus 2D into 1 divided by 5000. You can observe here, here all the values are in terms of D only. If you simplify this, you will get the D value as 1.91 meters. This is your depth of the channel. Next, he has asked you to find what is the average shear stress. Okay, while discussing the Chassis equation derivation, we have seen that the resistance offered for the flow, which will be balanced with the component of the weight of water along the flow. What is the component of weight of the water along the flow? So I'll write here. Okay, so the component of the weight along the flow, that should be equal to what, the resistance offered for the flow. Okay, so therefore I'll write the component of weight along the flow should be equal to what, the resistance, equal to the resistance. Now if I remember, resistance I have taken what as F only. What is the component? You observe Chassis equation, that is gamma AL into what, sine I. This I have explained while deriving Chassis equation, which is equal to what, F. Therefore the frictional, it is gamma AL into sine I. The frictional resistance is given by shear stress multiplied by wetted perimeter P into the length of the channel, what, L. Clear? Then here L with L cancel, then I'll take tau on this side, which is equal to what? Gamma A sine I divided by P value, which is equal to what is gamma? It is water 9810 into, so A by P is nothing but what? M. I can write 6D divided by 6 plus 2D, okay, multiplied by, it is for the small values of I, sine I is equal to I to 1 divided by 5000. You know already what is the value of D. D is what? 1.95 meter. You substitute, you get the average shear stress is equal to 2.28 Newton per meter square is your average shear stress. This is how you should find the average shear stress as well as what? Depth of the flow. Next, problem number 3. A channel of trapezoidal section with side slope of 45 degree to the horizontal conveys water at a depth of 0.75 meter. Find the width of the base and bed slope to the discharge as 1.25 meter cube per second with a mean velocity of 0.8 meter per second. Take C is equal to what? 65. So no doubt the given channel section is trapezoidal channel. So trapezoidal channel means I'll write the sketch. Okay, so this is what? The free surface of the water. So in this problem, he has given the depth as what? 0.75 meter. This depth he has given. Let me take that as D is equal to 0.75 meter. Base width, I'll take it as B. He has given clearly that it is the side slope making an angle of 45 degree with respect to horizontal. Okay, so this one you can make a correction, that is, okay, this is 45 degree here, 45 degree, it is 450, it has observed, it is 45 degree. Okay, so since I'll take this as what? The slope. If this is 1, this is n. If this is angle theta, if this is angle theta, this one is also having an angle 45. So if I take tan 45, which is equal to 1 by n, therefore n is equal to 1 by tan 45 is nothing but 1. The side slope n value is equal to 1. This is how you should find the value of n for an trapezoidal section. Okay, so depth he has given, the width he has given. So width you have to find here. Sorry, this will becomes B. Okay, so this is nothing but ND. You can observe the trapezoidal section what we discussed in the previous video. Okay, you know the value of N. So what else he has given? He has given the discharge Q. Yes, it is 1.25 meter cube per second. Then velocity V is given 0.8 meter per second. Then C is equal to what? 65. So let me write straight away. Then from the continuity equation, we can write discharge Q is equal to area into velocity. You know discharge as 1.25, area into velocity is 0.8. If you simplify, you will get the value of area as 1.56 meter square. Now the trapezoidal section area A is equal to what? B into D plus N into D square. You know area. So width is unknown, depth is 0.75 plus N is 1, depth is 0.75 square. If you simplify, you will get the value of B as 1.33 meters. Okay, so then wetted perimeter for trapezoidal section is B plus 2D root of 1 plus n square. You substitute all the values. B as 1.33 plus depth is 0.75 into root of 1 plus 1 square. You will get the wetted perimeter P as 0.452 meters. Then I can write M, hydraulic mean depth M is equal to A divided by P. If I substitute the value of A as 1.56 and P as 0.452, you will get the value of M, hydraulic mean depth, works out to be 0.452 meters. just make a correction here. Make a correction. The value of P is not 0.452. Sorry, it is 3.45 meters. And if you take A as 1.56 and P as 3.45, you get the hydraulic mean depth as 0.452 meters. Now, as usual, you write the velocity V is equal to C root of M into I. You substitute velocity as 0.8, C as 65, square root of M as 0.452 into I. If you simplify for I, this works out to be 1 divided by 2986. Even sometimes you can write in terms of decimal, that is 10 power minus 3 and all. That is also right. If I write that is in 1 in 2986 approximately, you'll get this value. This is how you should find the bed slope as well as the width at the base. That is B is unknown here. The width at the base you have to find. So in case of a trapezoidal channel. Next, problem number 4. A trapezoidal channel has a bed width of 4 meter and bed slope of 1 in 1500. The side slope being 1 vertical to 2.5 horizontal and depth of flow is 15 meter. Find first one average velocity, second discharge, third average shear stress at the boundary. Take C is equal to 50. So this problem is also on the trapezoidal section. So let me write the figure of trapezium. Okay, this is, I'll take it as base width B, uh, the depth as D I'll take. So he has given that the side slope of the trapezium being 1 vertical to 2.5 horizontal. So if I write here, it is 1 vertical to 2.5 horizontal. So in the derivation, so what we have taken as this is n value. So this is 1 in n means, so n value works out to be 2.5 here. So he has given bed width B as 4 meter, then bed slope I as 1 divided by 1500. The side slope, based on that only I have written n value. Then depth D as what? 15 meter. You have to find what is velocity, then what is discharge, and then you have to also find the average shear stress, that is tau value. Okay, similar to the previous case only, here you have to write what is the area of the trapezium. Area A is equal to BD plus ND square, which is area is equal to B is 4 into D is 15 plus N is 2.5 into 15 square. Area works out to be 11.625 meter square. Then wetted perimeter P is equal to B plus 2D root of 1 plus n square, that is B is 4 plus 2 times the depth is 15, square root of 1 plus 2.5 square. Then wetted perimeter P works out to be 12.07 meters. Then M is equal to A by P, that is 11.625 divided by 12.07, which works out to be 0.925 meter. Okay, so after finding the area, wetted perimeter and the hydraulic mean depth, coming back to the question, what else he has asked? He has asked you to find velocity, discharge and the shear stress tau. So but the velocity, which is equal to C into root of M into I, therefore velocity is equal to C, that is the C value he has given in the question as 50, then root of M is 0.925 into 1 divided by 1500. If you simplify this, the velocity works out to be 1.27 meter per second. This is your velocity. Then discharge Q is equal to area into velocity. Then area is 11.625, velocity is 1.27. If you substitute, you will get 14.71 meter cube per second. Okay. Then the third one is the average shear stress. This already we have did in the rectangular section, that is the same. So I don't want to explain again, which becomes what is gamma A L sine I is equal to tau into what? Wetted perimeter into length of the channel, where these two cancels. Then tau is equal to gamma A sine I, I'll take it as I only, divided by P. You know what is gamma? 9810. Area is 11.625. Then I is 1 by 1500, all divided by wetted perimeter 12.07. Tau works out to be 6.29 Newton per meter square is the answer of the average shear stress. This is how you can find velocity, discharge, and the average shear stress. Next, problem number 5. Water flows in a triangular channel whose sides include an angle of 65 degree at a velocity of 0.85 meter per second. Find the depth of flow. If the channel bed slope is 0.0016, take Manning's n equals 0.012. So this is a clearly an problem on triangular channel. So let me write the sketch of a triangular channel here. So this is the triangular channel. This is the free surface of the water. So I'll divide this channel. The total, he has given and include an angle of 65 degree. The total angle is 65 degree here. This complete angle is, I'll write here, it is 65 degree. So the each subtended angle is 65 by 2, that is 32.5 is the each subtended angle of the triangle. So let me take this triangle, this as O, this as A, this as B. So I take this each distance as X here. Okay. So in the problem you have to find the depth of flow D also. Okay. This the depth, I take it as what? D. D is the depth of flow. This too I take it as what? X. So from the triangle, though the center I take it as C. So from the triangle OAC, so in the triangle OAC, that is, this angle is also 32.5. All right. So tan 32.5, which is equal to opposite side X divided by adjacent side D. Okay. So therefore X is equal to tan 32.5 into D, which works out to be 0.637 times D. This is 0.637 times D. So in the same triangle, if I take the cos 32.5, which is equal to, that is D divided by hypotenuse is OA, therefore OA works out to be cos 32.5 times D, which is nothing but 1.185 times D. So keep this value of X and OA on one side, because OA is the sloping side. This will help you to find what is the wetted perimeter. Then X I also have written in terms of D, because since the D value and any one of the distance he has not given in the triangle. So let me write this, and I'll write area A is equal to half into basis 2 times X into what? D. Therefore area A is equal to half into 2 into X means 0.637 times D into D. The area works out to be 0.637 D square. So area also have written in terms of what? D here. Next, wetted perimeter P is equal to OA plus OB. You can look at the sketch. This is OA and OB, which is nothing but P is equal to What is OA? 1.185D. OB is also same. OA is equal to OB in case of this triangle. So P is equal to 2 times 1.185 D, which works out to be 2.37 times D. This is the wetted uh, perimeter for the triangle here. So next I'll write what is the value of M here. Hydraulic mean depth M is equal to area divided by perimeter. You substitute the value of area and P, square with the D cancel, then M value works out to be 0.268 times D. So we have got area in terms of D, wetted perimeter in terms of D, M in terms of D. Now let me write the velocity equation of the Discharge's equation. The velocity V is equal to C into root of M into I. So now you observe this question whether C value is given or not. So he has not given the value of C, instead he has given the Manning's N. So therefore I'll write V is equal to Manning's N in terms of C 1 by N into M to the power of 1 by 6 root of M into what? I. You know that that is the velocity he has given in the problem, that is 0.85 meter per second. You substitute the value of velocity as 0.85, which is equal to 1 by the Manning's N is 0.012 into M. You substitute in terms of D, that is 0.268 D to the power of 1 by 6 into 0.268 D to the power of half, root I have taken as half, into I value as given as 0.0016. Now everything is in the D only. If you simplify, D value works out to be 0.481 meter. This is for an triangular channel whose side included within 65 degree. The depth of the channel is 0.481 meters. Next problem number 6. Find the discharge through a circular pipe of diameter 3 meter if the depth of water in the pipe is 1 meter and it is laid at a slope of 1 in 1000. Take C is equal to 70. So this is the problem based on the circular section or the circular channel section. So first I'll write the sketch of that one. The diameter is given as 3 meter here. This is the circular, this is the center. Now in case of circular channel, always you have to mark the depth of flow, whether it is greater than the center or below the center of the pipe. Okay, in this he has given the diameter of the pipe as 3 meter, means the diameter of the pipe as 3 meter means this is 1.5 meter. This is 1.5 meter, correct? If that is 1.5 meter, if the depth of water in the pipe is 1 meter, means it is always below this 1.5 only. So this is your water surface. This depth I'll take it as what? 1 meter is the depth of flow. D is equal to what? 1 meter. Now we join these two. Just go through the derivation in the previous video. So this I have taken as theta. So this also we have taken as theta only. This is the center O. This is A. This I'll take it as P. This I'll take it as C. Okay. So in this you can write. Okay. So what else he has given? So slope value is given. I is equal to 1 in 1000. C value he has given as 70. The diameter is 3 meter. Capital D I take as 3 meter. Radius is 1.5 meter. That is 3 by 2. 1.5 meter is the radius. So here, in case of circular section, the very first thing you have to do is finding the value of uh, theta value you have to find. In order to find the theta value, if I take any triangle that is OAC, I know what is the OC distance. OC is equal to total is 1.5 minus of 1, that is 0.5 meter. Theta is unknown. This OA distance is nothing but the radius only. This is 1.5. So from the triangle OAC, if I apply cos theta, which is equal to adjacent side, that is OC. OC is zero point 0.5 divided by the hypotenuse is 1.5. Then the theta value for this works out to be 70.52 degrees. Why we have to find the value of theta? Because area as well as wetted perimeter and the hydraulic mean depth will dependent upon theta only. If you find the value of theta, you can find the area, wetted perimeter and all, because in this problem you have to find the value of discharge here. So the area formula for the circular section is r square into theta minus sine 2 theta divided by 2 here. Okay, so sine 2 theta by 2. I substitute what is r, 1.5 square, theta is 70.52 into pi by 180. You have to convert into radians because another theta is in with the trigonometric function. Therefore, sine 2 into 70.52 divided by 2. If you simplify, the area works out to be 2.06 square meter. Okay, that is the value of area. So once you get the value of area, wetted perimeter is 2r theta. You substitute, the wetted perimeter works out to be 3.69 meter. Then I'll write m is equal to area by p, which is equal to 2.06 divided by 3.69. M works out to be 0.55 meter is the value of m. Once you get the m value, we know that discharge is equal to area into velocity. Velocity is c root of m into I. You substitute what is area, 2.06, c value is 70 as given, root of m value is 0.55 into I value is 1 by 1000. If you simplify, you get the discharge value as 3.34 meter cube per second is the value of discharge Q. This is how you should find the discharge in case of a circular pipe or the circular channel section which is running less than half full. Next, problem number 7. Water is flowing through a circular channel at a rate of 400 liters per second. When the channel is having a bed slope of 1 in 9000, the depth of water in the channel is 0.8 times the diameter of the circular channel. If the Manning's n equals 0.015, find the diameter of the channel. So as I told earlier, you have to first decide whether the channel, whether the depth of flow of the channel is greater above the center of the channel or below the center. So first we'll decide that one. So I'll take an circular channel here of diameter d and radius is r. This is the center of the channel. So in this problem, he has given that the depth of water in the channel, that is depth of the water d in the channel, is 0.8 times the diameter. 0.8 times the diameter means it is above the center of the channel. So this is the depth of flow. That depth of flow is nothing but 0.8 times what? D here. That is the diameter, capital D. Okay, so let me join this two like this. I take this as O, this as A, this as C, this as what? B. So here, in case when the water depth of flow is above the center, so if I take this as dotted line, if I take this will becomes an angle, what? Theta. This angle becomes an theta. So in the previous case, the depth of flow is below the center. So where I have mentioned theta, that is correct. Here this 2 becomes as in theta. So I'll take this angle as alpha here, alpha here. So let me write O C distance here. So because this is center is nothing but, it is nothing but the radius, that is d by 2, d by 2. Okay, then from the figure OC is equal to 0.8 d minus d by 2. So OC is equal to zero point 0.3 times d. The diameter you have to find here. OC value you got now. Then this OA is nothing but the radius, that is d by 2 only. OA from this triangle, from the triangle OAC, cos alpha is equal to this OC divided by OA value. OC by OA. What is OC? 0.3 times D. Then what is OA value? That is nothing but D by 2. If you simplify, and you will get the angle alpha is equal to 53.13. Alpha is 53.13. From the sketch, it is clear that theta is equal to 180 minus alpha. You know the value of alpha. 180 minus 53.13. Theta value works out to be 126 degree. Okay, 126.87 degrees. 126.87 degrees is the value of theta. So here theta value you already know. So depth of flow is 0.8 times d. Then the discharge value as given. Okay, so discharge value as given as 400 liters per second. So 400 liters per second. Therefore q is equal to liters, you have to convert into meter cube, that is 400 divided by 1000. It becomes 0.4 meter cube per second. Then slope is given as 1 by 900, that is I is equal to, sorry, 1 by 9000. It is I is equal to 1 by 9000. So let me start with the area. Area A is equal to r square theta minus sine 2 theta divided by 2 here. Therefore area works out to be, radius I will write d by 2 whole square. Theta is 126.87 into pi by 180 minus sine 2 into 126.87 divided by 2. If you simplify, area works out to be 1.347 d square. So area also I have got in d square. Wetted perimeter P is equal to 2 into r, that is d by 2, into theta 126.87 into pi by 180. So wetted perimeter P works out to be 2.21 times d. Now if I take what is the value of m here, m is equal to a divided by p, that is 1.347 d square divided by 2.21 times d. Then m value works out to be 0.608 times d here. Okay, 0.608 times d. Now I'll write the discharge equation, that is q is equal to area into c root m into I, that is discharge is 0.4 is equal to area is 1.347 into d square. C value has not given in the problem, instead he has given Manning's-N. Therefore 1 divided by n is 0.015 into m to the power of 1 by 6. But what is m? It is 0.608 d whole to the power of 1 by 6 into 0.608 t whole to the power of half, then into what is I value as given, 1 divided by 9000. You can observe only d is unknown. If you solve for the d, you will get the diameter d as 1.26 meter. That is the diameter of what? Circular channel. So that is what he has asked in the problem. That is when the water is flowing through circular channel at the rate, okay, so times the diameter of the channel. So find the diameter of the diameter. If sometimes if we ask what is the depth of the channel, it is very simple, that is depth is equal to 0.8 times d. You just 1.26 multiplied by 0.8, you get the depth of flow also. So we'll do the depth of flow. It is almost equal to 1 meter. You get the depth of flow as 1 meter you'll get if you take zero point 0.8 times 2. This is how you should solve the problems on the regular channel section. Okay, thank you so much.